person just came in from, okay. All right, so we'll go ahead and formally get started. I want to welcome everybody. I'm going to start by saying, who do we have on board today that's not been here before? I've looked at the list real quickly, and most of the people I'm familiar with. Anybody has not been to the workshop before, please unmute and say hi and tell us who you are and where you're located.
I guess I can go first. My name is David Lang. This is my first time. I'm in Charlottesville, Virginia at UVA, and excited to be part of this group.
Okay.
Hi,
Anybody?
This is Maruf Haider. I'm an internist and informaticist in Falls Church, Virginia. It's my first class as well.
Great. Okay, well, it's nice to have you here. We always appreciate having people in different levels of healthcare and different universities and so forth. So that's terrific. All right, so second thing is, please take the poll. If you go up, look at your menu, you'll see poll quizzes. Please look at that, and it's a one question poll of just, do you think 60 minutes is ideal, or could you go 90 minutes? Just because we got a lot of stuff to cover, when we finish visualization, we'll go to modeling, which is really important, predictive modeling. And then the next chapter will be, how do you evaluate the predictive models, which is super important. So it's conceivable that 60 minutes is not long enough, but we don't want to browbeat you. These sessions are not as interactive as we'd like to be because they're not live. So please take a moment and just tell us whether you think 60 minutes would fit your schedule better or 90 minutes. And it's anonymous, by the way. We had no clue who's answering what. And so I didn't realize I had to launch it. So. And I suppose if it's fairly tied, we might decide to go an hour and 15 minutes or just make some compromise, but we'll just have to see. Okay, you all, I'm going to go ahead and end the poll. It's really pretty split. 53-47, 60 minutes versus 90. I think if it's at all democratic, what I think we'll opt to do is we will break just before the hour, and we might not do it today, but from going forward, we'll probably take a break for questions. People can go get coffee, bathroom break, and then we'll go another 15 minutes. But I think that would be the compromise. Because again, it's a Saturday. I realize that you've got family, you've got other chores and stuff you need to do. Okay, so that being said, let's move along. I do want to remind you, well, first of all, given the fact that we have a couple of new people, I want to give a little overall orientation of what we're trying to do. This is not a purely AI workshop. Why? We feel that AI needs to be data-centric. Machine learning needs to be data-centric. Otherwise, it's garbage in, garbage out. If you have bad data, quality, quantity, you've done nothing to take care of missing data, outliers, all the rest, then your model, regardless of whether you're using a neural network or you're using logistic regression, is not going to be as good as it ought to be. That being said, as clinicians, you need to have some feel for sensitivity, specificity. How many false positives are you willing to accept? Likewise, if you're reading a new article, and there's so many of them in the informatics realm, now include articles about machine learning and AI, you need to be more knowledgeable about some of this background stuff. So we want to teach way more than just AI. I want to make that clear. Now we have some of you may not know, we do have a textbook. It's really a little bit like building an airplane when you fly it, because even the partial chapter I sent you, we've already changed somewhat. We've added more visualization to it. So it's not a done deal. This is kind of a draft textbook. We hope that it'll be finished by mid or late summer. But what is the end goal for us? The end goal is probably having a certification course at different levels, so people can say, I'm certified in data science at whatever level. And David is the guru on that. He can address that further if he chooses to, but he's certainly been the leader on that. We're going to center this approach on no coding, no programming, largely using the program Orange, which hopefully all of you have downloaded. Secondly, we use JASP, J-A-S-P, another open source stat packages that does some things better than Orange. And thirdly, once in a blue moon, we may use Blue Sky Statistics. It's also open source. You can get it free. It's a Cadillac, but it's not nearly as intuitive. It isn't something you can operate without reading any instructions. Whereas Orange and JASP, you pretty well can get started. It's so intuitive. So that's just the orientation for the new folks. It will probably be several sessions on every chapter. There's not any chapter that we can get through in 1 hour, I don't think. So just we can review that later. So we will be doing more. We'll do time series. We'll do image analysis, text mining. Dave's going to talk about Lean Six Sigma. We'll do geolocation. We've got some really interesting stuff in the months to come. So again, with Orange, be sure you go up to the top menu to options and then go add-ins. That's where you'll see under Orange, you probably have version 3.34, upgrade to version 3.35. You'll need that when we get to modeling. That's the latest and greatest. So you just go to the top menu to options, then add-ons, and then upgrade anything that's ready to be upgraded. All right, a couple of reminders. There's a Medical Intelligence Society Summit, July 28th and 29th. If you're already a member of the MIS Society, it's free. I strongly urge you to become a member. It's one of the best conferences I know of. It's virtual. And it's also the meeting every month is one of the best I've ever attended. The first hour is about AI and data science. The second hour is medical innovation. So the $100 a year for a practicing physician is pretty cheap. It's less if you're in training, like you're a resident, it's $25 a year. If you're truly a student, it's free. But I strongly encourage you to go to missociety.org, sign up to become a member. Second of all, the big AI conference that I'm involved with, AI Med Global Summits, in San Diego, June 4th through the 7th. Again, in San Diego, should be about 1,000 people there. That is purely an AI conference. They won't be talking about data wrangling or cleaning or any of that stuff. It's purely cutting edge AI. The only thing I want to announce is I do have some free passes. If for some reason you can arrange transportation, you can get hotels, whatever, and you would love a free pass for registration, email me and I'll take care of that. All right, let's talk a little bit about ChatGPT or generational models or generational AI or large language models. They all fall into that same bucket. ChatGPT, which is 3.5, came out in November. It was followed in April by GPT-4. As you know, generally to sign up, you have to pay for it. And it's $20 a month. I got news for you. There are lots of plan Bs out there. If you like GPT-4, first of all, consider Bing Chat, not Bing, not Microsoft Bing, but Microsoft Bing Chat. That is GPT-4. But what's unique that they don't advertise, which they sure as heck should, is it includes references. Excuse me. So if you look up a topic, and let's say it's medical, they'll probably quote something. It could be the literature, but it might be MedMD or something like that. But the point is, to me, that's huge. I'm not very happy looking at medical stuff on ChatGPT with no references, because one of the major complaints is it makes stuff up. That's called hallucination. That's a downside of the chat box for healthcare. The other one I'm going to mention, and hopefully you can see my screen, is called Perplexity AI. It's free. And let me just put in here, let's see, what is model validation? You've got, first of all, you can make it academic. Let's make it academic. I click that. You can get a quick answer, which would probably be internet. But look, if you do enhanced, enhanced is ChatGPT, and it gives you 20 uses over a 4-hour period. That's pretty liberal, I think. So let's just do the enhanced one. And so it's going to think for a second, of course, and then it's going to spit out the answer for you. And then you'll notice that it'll cite, you'll notice that it's citing references, but it also gives you the ability to ask related questions down here. So, excuse me, I have no vested interest in Perplexity AI. It's simply that these large language models would be a much better sell for people if they include references, so you know how they think. So I do recommend Chat or Bing Chat and Perplexity AI for that reason. Now, newer yet than either of these is the whole realm of auto GPT. That's the idea of what is it? Can a large language model give its own prompts and keep going? The answer is yes. I think it's so new, we don't know quite how good it is. And also auto GPT, you have to activate using your own terminal. You have to write code. Along comes agent GPT, which is browser based. Excuse me, it's largely autonomous. But for a lot of these, understand that what you have to do is you have to have an account with OpenAI, because if you run over a certain limit, it's going to stop. And it's very cheap to do it. You're buying tokens, you're buying words, basically. So that is very inexpensive to do. Now, let me take it a step further and just say that there are now, I hate the name, it's called God mode, G-O-D mode GPT, which is semi-autonomous, where you tell it what you want. I want you to create a model to predict who survives on the Titanic using logistic regression, and it'll break it up into tasks.
Play something got read, didn't we?
Yeah.
It'll stop and ask you.
Yeah.
Can everybody mute, please? We're getting background noise. So
I've been changing my t-shirt in a minute. Looks like I called it over.
okay, please, would everybody please mute? Okay, so in the background, it thinks, it asks for more information. It says, do you approve of this plan? And lastly, it creates files. So it creates a whole game plan for you, and it includes the files of what it did, what it researched, and the Python code, let's say. So just understand, autonomous GPT is probably a new evolution off of Chat GPT. So it's really a difficult area to get your arms around because it changes by the week. So when I talk to you a month from now, I may be singing a whole different song because it's moving that fast. As somebody quoted a week ago, said, "You don't like the AI you see today? It's the worst you'll ever see." Meaning it gets better so fast. Don't be too critical because it's changing rapidly. Also, keep in mind there are 10 biomedical large language models about ready to launch. So, meaning they've trained on PubMed, they've changed on, and that brings me to the last large language model that you all should check out called Glass Health, GLASS Health. Basically, they have first of all, they have a medical knowledge base that's augmented by a lot of physicians and specialists, but the search engine is a large language model. They've created modules on common diseases like COPD, lung cancer, coronary artery disease, and so forth. And so your search engine is a lot more intelligent than you going to UpToDate or just going on the internet. And they continue to add more and more modules. And they're so you can test it for free. And that's what I strongly suggest you do. And their pro version is only $12 a month. So I think in the future, you're going to see tons of programs, even like UpToDate, will no longer have a standard search engine. Why? Because you can go in and say, I have a 19-year-old woman with pulmonary hypertension and lupus. What is the differential diagnosis? What is the treatment? So Glass Health divides it into differential diagnosis and what is the treatment plan. I strongly encourage you to check that out because I think you're seeing a glimpse of the future. Okay, with that, I need a little water from my voice, and I'm going to go ahead, Dave, I'm going to stop my share and let you take over.
All right. So let's see, the first thing I'm going to cover before we get into the chapters, there's a few different things I want to go over. And one of them is, this is a question that Scott brought up last time and said, hey, how are you guys going to deal with the over 200 different widgets that you have in Orange? Are you going to cover all of them? Well, let me first of all show you what we've done here. There's, as you can see in the far left, if you update everything and all the widgets that are available within Orange, you'll find that you have 21 different categories on the far left. And if you break each of those categories into a little matrix, or that the further up you go vertically on this graphic here, it's more complex. And if you go right or left, you can see the topic, whether it's about tabular data, text data, images, or specialty topics like genomics and some other things. You can see how it's broken out. So yeah, there's a lot of interesting things going on within Orange and how their widgets are broken up. And are we going to cover every one of these widgets in the book? Not quite. We're going to pick out the ones that are the most mature, the ones that work the most, have the highest performance of working, they're the most reliable, and those kind of things. For example, there are some widgets, for example, if you want to download some stock information, that one, for example, earlier this year started to crash and they're not quite sure why. So we're not going to recommend some of those. Now, one thing we are doing, Bob mentioned earlier, you know, our goal eventually is to turn the textbook into the basis for multi-level certification. And this is just an absolute start of all of the widgets that we're going to use within Orange for our book and also for our certification levels are going to be shown in the type of matrix. And I hope I could squeeze it into one graphic. And I'm also going to squeeze in here all the JASP tasks. And then also in blue, all the normal to-do lists. So it's going to be broken out by those types of 3 color codes at the moment. And if you look at the very bottom, what are the different types of certification levels we are thinking of?
We cannot see your screen. We cannot see your screen.
You cannot see my screen. Okay, thanks for saying that. Well, that's probably because I forgot to say share. How's that sound? Let's see here.
There you go. Thank you.
There we go. And we'll send this out to you, by the way. And so the slide you couldn't see before is all the different categories of orange that are broken out into the different categories I mentioned and how many of them there are. But okay, getting back to how we're going to break out these widgets and JASP tasks and also normal to-do tasks that are not exactly attached to a piece of software. Well, you can see on the left, there's 8 different steps, and those 8 different steps are what we showed in the book. And in the meantime, I'm going to get into that as my next topic. We've broken that out into still the 8 steps, but we've renamed that into the word which we call the acronym, which we call Discover. And I'll explain in a minute what that means. And it walks through sequentially the data science process. And if you can see in the bottom here, we're going to have, you know, a junior data explorer, probably a data explorer, visual analytics specialist, machine learning predictive analyst, and then also something we'll probably call a master no-code data scientist. And then for each one of those, we'll show exactly what are the tasks that are associated with JASP and the widgets associated with Orange. What are those that are associated with you if you're pursuing those levels of expertise? And so we're working on that in the background, and eventually this will move in that direction. And also, it's not just medical. We're offering, you'll notice that the book will be diversified more and more over time. And we're going to be including a lot of very general interest topics beyond just medical, because we want to make sure that we cater to a general community that's interested in these certifications. So you'll see that more diversification in the data set. So another thing I want to show you is, let me know if you can see this screen.
Yes.
Yeah.
Okay, good. So here we have our Discover process. We have our 8 steps, and we call that Discover because we have it broken down into this acronym, which I'm going to read off very quickly, and you'll start to notice that this is incorporated in the book. So we have a define phase, which is, you know, you're going to define your research questions, problem, and your goals. Then you're going to integrate. You're going to integrate the data and then collect the data of high quality data. It's a very important part after you've defined your research goals. Then the third step is scrub, clean, and pre-process your data. It's a huge section. And then we have also, you know, cultivate the insights with exploratory data analysis, which includes data visualizations, which is a topic we're going to cover today. And then we have, you know, modeling, and as soon as you touch a model, the first thing you're trying to do is optimize the model. So we're calling this step 5 is, you know, optimize models with fine-tuning techniques. Then we have the 6th step, you know, verify model performance with optimal metrics we're going to get into, and then explain insights effectively to stakeholders. Because if you can't explain and convince things to stakeholders in your organization and internal, external customers and patients, whatever you're doing is not going to fly because it's not going to have the credibility or the trust. So those are all, the first 7 are incredibly important. And then the last step, obviously, is once you've launched this as an active model and maybe as an AI app, you want to reevaluate that model over time and make sure that you counteract any type of what we refer to as model drift. Now, each of these steps have a very detailed list. You know, this is basically the entire book, the roughly 500 pages that it's going to be at the end. But each of these steps, these 8 steps, has a lot of supporting activities, and they're mentioned there in the book, or they will be mentioned in the book. So what we've covered so far is step 1, and then step 2, you know, integrating, you know, high quality data. There's a lot of steps with that. The entire part, which we call, you know, scrub, pre-process data, and data wrangling, that has a lot of, you know, in general, that's about 25 steps right there. And then what we're going to start to cover today is, you know, cultivating the insights with exploratory data analysis, and then also the data visualizations. So that's very important. And then, as we said before, this process is not always linear. It does go backwards in circles at times, because as you go forward in your data science process and your modeling process, you find some issues and you have to go backwards to fix those issues. And then you continue on to move forward from the current point or the old point. So, and I skipped over some of this, and because obviously a lot of this is included in the book. But can you see now this Excel document that I'm showing?
Yes.
Okay, good. Now, for this chapter 3 that we're going to get into as soon as I'm done here, is we're actually going to show you what turns out to be is 34 different types of data visualizations. And this cheat sheet we're going to also make available to you. We're going to incorporate it in the book. But the important part is we're going to have not only just a list of all the data visualizations, but break them out into the category type they are. What is their purpose? What supporting statistics do they include? And what's also important, oh, by the way, can I do this in orange, JASP, or in blue sky? And then so there's a little marker there, and you can see as you scroll down here, and I'm not going to dwell on this or try to read this, but to show you that we have also these cheat sheets that we're going to make available for you. So that pretty much covers my topics. And let's see, Bob, I'm going to hand it back over to you. I'm going to stop sharing.
Okay, and I'm the only thing I have left before we get on to the book is homework. I did attach the homework for today on data visualization to the chat, so please look at it, download it. I'll briefly go over the homework from last time, which was fairly straightforward, with just attempting to do a couple of things. Number one, edit domain. There are some silly, when you look at the heart disease database, there's a couple of silly things, like instead of diameter narrowing, it should just be heart disease, yes or no. So you can change that. You just retype it. Major vessels colored really should be calcified. You're looking at how many arteries, coronary arteries are calcified. You can change that and just hit apply. And if you want to verify you did it correctly, you just hit data table and see that it says heart disease. And if you want to do that from now on, you can just save the data with a new name, like heart disease edited or something. That's all that is. Under correlations, just want to get you used to looking at Pearson correlations, where you're trying to see what's correlated with what. You like it if the say age is correlated with the diagnosis, but we will talk, we already did in chapter 2, talk about, you also want to see if two predictors are they're overly correlated with each other. That's called multicollinearity, particularly those things that are over 0.7, let's say. So this just happens to give you, this was a search for all combinations. So the first one that popped up is age and maximal heart rate. Not a surprise that people that are elderly don't achieve as high of a heart rate on a treadmill. So it's just getting used to positive and negative correlations there. Continue-wise is just, again, to get you to understand that computers tend to understand zeros and ones better. So often, if you continuize the data, the computer does a little bit better. We'll talk further about dummy encoding. We already covered it in chapter 2, but we'll talk about it a little bit more in chapter 4. And you can continue, you can look at what you accomplish by always attaching a data table and seeing how the data changed after you used the widget, the continuize widget. And lastly, the feature statistics, it was simply a matter of looking at the difference between median and mean, with the idea that they should be very similar. If they're very far apart, your data is not well distributed. Because remember, median is the middle, mean is the numerical average, they should be very close. And I think the answer was cholesterol was the one that showed the most difference, hence is not normally distributed. So again, you've got the homework. We'll go over it briefly next time, and just email me if you have questions, but I don't want to spend more time on it than that. So let's see. So Dave, I think if I have the right section here, we're going to turn it over. I'm going to stop share and let you start on the textbook.
Got it. All right, so I shared my screen now, and let me know when you see something popping up pretty soon.
We see it.
All right, good. So this is chapter 3. And what is chapter 3 all about? It's all about data visualization. And as I mentioned, as I showed you on that Excel cheat sheet, we have 34 different types of visualizations that we're going to cover in this chapter. And most of them are covered in orange. And then when JASP does a little bit of a better job or does something that orange can't do, we're going to notice that, mention that. And also when Blue Sky Statistics also offers something that the other two don't offer, or offers a better twist on it, we'll offer that too. And why are we doing that? Because they're all free, they're all open source, and they're all dramatically improving. And it's not like commercial software, you complain about it and then maybe something gets changed. Like for example, in Blue Sky Statistics, I was complaining about that they didn't have options on their time series plots for how thick to make the lines when you're showing multiple lines in the same time. And within 24 hours, they sent me the code that I could add to make that change. And they said, use that code for right now, but the next time you see an upgrade, and they upgrade probably every 2 months, you will see that change. So that's how quick they do some of these changes. And also, orange is, the larger the company gets, sometimes the slower they are to react to it. So data visualization. Why is it so important? I showed you very briefly in the discover process of, what are all the bullets under each section, but I'm going to slow down and read through some of those as we go through this visualization section, because it is so incredibly important. And this visualization is rather interesting because it's not only just going to show something that looks good that anybody else can understand, but very often they also include statistical numbers and statistical tests, hypothesis tests, things like ANOVA, t-test, and regression analysis, etc., normality tests. So they do require sometimes some statistical knowledge that we also make sure that people understand. What we don't cover in this section are things like Tableau and Power BI in all details that Excel might offer. We talk about mostly what the 3 types of open source softwares that we mentioned so far. But here is what some of the reasons and the purposes for why you actually would want to do a data visualization. And keep in mind, when you're doing data visualization, it is part of something that we call the acronym EDA, Exploratory Data Analysis. So it's not just visualization. Visualization is part of exploratory data analysis. And the reason I say that is because sometimes this visualizations includes tables of numbers or statistics, which is kind of like visual. It's not in a graph format, but it is part of this section. So what's the purpose of this whole thing? Well, first of all, we're trying to simplify complex data patterns and make them easier for you to understand and to communicate. And again, back to the word communicate. If you can't communicate and convince others on where your analysis is going and how you got to your conclusions, you're not going to get the support of stakeholders. You're not going to get the support and the belief and the trust that you need from internal, external customers, compadres, stakeholders, and patients. So it's very important to make sure that you can communicate, when you're talking to somebody that wants to know exactly what you did in your analysis. And you want to make some also some quick insights. The beauty of this entire section is it's not real heavy on machine learning modeling or gray box or black box, but it's trying to distill anything you do in as visual a format as possible, so that when you actually share it with a stakeholder in your organization or external, that you can hopefully agree on what the conclusion is just based on the logical interpretation of the graphic. And that's very important. And the main challenge, what we try to do in these visualization section, is to really enhance comprehension and understanding on very complex situations. You know, any time we're trying to predict, diseases or any other complex topic, we're pretty much getting into very rapidly into complex data analysis, not real simple stuff. Even if you look at something that we might even consider simple, all right, who survived on the Titanic? Well, yeah, that's a pretty loaded question. It's a multivariate question. It depends your age, your gender, what class you were in. It's a multivariate, very complicated situation to explain. But there are very unique and very compelling visualizations that on one graph can tell an entire story that would take you a long time to explain. And as soon as you explain it, people start to forget it. But the beauty of visualizations is they're going to remember it. And if you look at the bottom, people are going to remember a good visualization. It's really going to help their memory and their recall compared to just if I threw a table of numbers at you. Unless, I mean, there are people, I've known people that have a photographic memory, and they remember numbers for a very long period of time, but most of us don't quite fall into that category. And it also, visualizations help us to, compare, data results between different groups. Let's say I'm looking at diabetes and I want to compare different ethnic groups, or I want to compare different gender groups or other different types of risk groups in that, in that category of disease by age or whatever. Visualizations can do a really nice job of breaking that out. And then also, if you get a well-crafted visualization, you could also engage an audience quite well. They're going to be looking at it, they're going to try to understand it, they're going to try to, and if you do the same presentation just with a bunch of tables of numbers, you're going to lose them and lose their interest. So, and again, we can't get away from tables at times because they are interesting, but it's very important to sprinkle in some very powerful visualizations. And they're going to support our decision making, because what are we trying to do with all this analysis? We're not only trying to entertain people intellectually, we're trying to support some type of decision-making process for the stakeholders, or for the, the medical clinicians, for the experts. So we're trying to do that. And another beauty of all these visualizations, it gives us another second look and an additional check on data quality. And when I say data quality, if one of your charts shows you that you got 5 data points that are totally unrealistic, you're expecting numbers from 1 to 10, and all of a sudden you see 5 data points that are in the hundreds, right away, just by looking at the visualization, that something's wrong with that data, and somebody should have gone back and cleaned the data before they made the graphic. So that's another beautiful part of these visualizations, another check. So there's just so many other advantages you could read here. I just don't want to read through all of them, but it's so incredibly powerful if you do this right and you break it out into the correct pattern. And the discover process I already mentioned. So where are we right now? We're in section number 4, step number 4, where we're cultivating insights with exploratory data analysis, which includes, data visualizations. And so what are we doing? And why this is a very interesting concept. It's a very famous concept. I didn't make this up. It's a data set called Anscombe's quartet. And the beauty of it is that the correlation of this data, this X1 according to the Y, is exactly the same for each one of these 4 very clearly hugely different data sets. And the important point of this concept is that when you're looking at just numbers, it's not a good thing. You need to have some types of visualizations so that you really understand what's going on. I mean, have a look at how incredibly different each one of these data sets are, yet they yield the same blue diagonal trend line in the linear correlation. Again, linear, make sure it's linear correlation between the X1 and the Y1. So you always need to have a combination of looking at both things when you're looking at your data. You want to look at the data itself and supported by visualizations, and then make sure that you analyze it correctly so you don't end up in this type of trap here, or that you might just, sometimes you could show a graphic that includes just the line and not the dots of the raw data. And that, if you did that, you would have the same 4 blue lines with the same angle going, the lower left to the upper right. You'd have the same trend, and you'd say, okay, they look all the same to me. So again, when you go back and look at the raw data, you get a lot of different insights. So always keep that in mind. And these are fundamentals of data visualizations. And again, of these 34 different types of graphics we're going to show you throughout this whole section, we're going to get into univariate, bivariate, and multivariate types of analyses. And I'm going to cover some of the more mundane and statistical and numerical tables first, because we want to make sure you understand that they're important before we hop into the more exciting data visualization parts of it. But these graphics here, they just start to make sure that everybody understands what is a mode, what's an outlier, what's a median, what's a mean, what's a difference, and those types of things. And then, here's a graphic here that shows us if we do a box plot, and if we see these little dots outside of these what we call fences of the box plot, we could tell that that is a statistical outlier. It's a data point that belongs to the data set. But again, we have a visualization here that allows us to see not only breaking out the data in quartiles, but also if it is outside of this quartile and is considered a statistical outlier. And then we also have, lots of different types of distribution plots, which also tell us if the data is skewed and things like that. So those are all very important topics. And we could also quickly see if we think the data has a normal distribution. When I say we think, because we got to be careful, because not every data set that looks like a bell curve is what we call a normal distribution of data, or what we call a normal bell curve. And a normal bell curve has this breakout of the data. It doesn't have 99% in the middle. It has 34.1% on each side of the mean. So there's a certain type of distribution shape that normal data also has. And then we have something that's called positive skewed and something that's called negative skewed. And what is that all about? Well, positive skew, how do you know the difference? Well, we call this the tail. What I'm circling right now, we call that the tail. And whatever the tail is, we call that then positive skewed. Positive means larger numbers. So it's skewed toward larger numbers. This example on the left is what we refer to as negative skewed, which means that the tail, or where we have the least amount of the data in this distribution, is headed toward the lower types of values. And so we have pivot tables, and I'm sure a lot of you are familiar with pivot tables, but we get into that. And we have some software that does that. We have a bunch of feature statistics, and then we have descriptive statistics and state tables. And again, number tables can tend to be a little bit, you can't dwell on them and have really a deep conversation with a lot of people, but they do offer a lot of very interesting information about the data prior to us jumping into a visualization to show that. And we have in JASP, we have a lot of different frequency tables and a lot of things that we could look at that'll break out the data into a variety of different tables of interest that'll help us. Then we have something interesting called we have here a stem and leaf diagram, which is a very interesting type of diagram. And it's like a histogram laid on its side, but it's also telling us Like, what is the third digit? Like, let's see, these are all, this is all 3 digits, right? And the lowest one here is 126. But the second one, you see, I got 3 data points. What's 141? And I got 2 149s. And then this one over here, you can see it's a data distribution histogram that tries to show you, if you are interested in that, the values for each individual data point in that distribution. So that's another unique type of data visualizations. Then we got the correlation matrix that Bob covered a little bit and showed in the homework. And there's a variety of different ways that we have within Orange and JASP that can show these types of, if you have like 6, 7, 8, 9, 10 predictors for a certain disease or a certain event, and you're trying to find out what's the correlation of each of my predictors, you could get a variety of tables that tell you exactly what is the correlation level of those predictors, and oh, by the way, what's the statistical p-value? Or if you'd rather have a visualization, we also have within JASP, it offers a visualization, which it takes those numbers and says, all right, blood pressure versus age. What's the correlation between those two? And on a scale of 0, -1 to +1, well, it's on a scale of 0.273. Where that the darker the blue is means it's a positive correlation, and the darker the red is a negative correlation. So these are what we call Pearson correlation heat maps. So this is taking a data table, turning it into a very visual heat map. So what I'm going to do now is hand it back to Bob, and he's going to walk through a series of additional visualizations here for our purposes. So Bob, I'll give it back to you.
Okay, thanks, Dave. What I may do, I may break trend here and actually use the diagrams or the actual programs to give you something above and beyond the textbook, or just for those of you, and there is bound to be a couple of never seen JASP, again, a free open source stats packages that's really quite amazing. You know, here you just go to open, you select, it says recent files, here's heart disease, which we used in Orange, same file. So under descriptive statistics, for instance, I have cholesterol and maximum heart rate divided by heart disease, if you will. So here is the table up there that shows you information that's important, but you can check all these statistical options here. And then you get down to visualization here, and I chose box plots and use color palette. I wanted to choose blue and red, which is what Orange did, but I don't have that option. But you can see here, this is cholesterol with the presence or absence of heart disease. And you can see out not only outliers, but they label this is patient number 182, let's say. So that's really a very cool option. That, again, this is where JASP is probably a little superior to Orange, is with basic descriptive statistics and some visualization. The two complement each other. But again, this is why we do recommend you understanding JASP, have it available as well. It's well worth it. And then while I'm in this area, I want to demonstrate a rain cloud plot, which Dave and I really like. I went to went to t-test above, selected independent samples, and for the dependent variable, I put cholesterol, and down here we group it by heart disease. And what it does is it gives you a combination of things. You see the actual data points here in red. You see a box plot above it, and then you see distribution, which is pretty impressive. So for those people with heart disease, the cholesterol is more normally distributed than those people without. So I just wanted to, again, want people to play around with JASP. We'll be using it off and on, not nearly as much as we use orange, but it's a workhorse, if you will. So let me pull up, let's see, the demo. So I'm going to talk about the tree viewer. To view this, you have to connect it to tree. Can you see this okay?
Yes.
Okay, so you open up tree viewer. You have to play with it to get it on your screen, so you have to just play with zoom and width and whatnot to get it to the point where you can see it properly. And the other thing, which is really handy, is pruning it means that you don't want the tree to keep dividing forever. I mean, again, if you say 9 levels, this is what it looks like. What is the problem with that? The answer is that if you allow the tree to keep dividing, it will divide on garbage, noise, not signal. And so the model eventually might look good in training, but when you test it on data it hadn't seen, it does poorly. That's known as overfitting, which we'll cover in the next chapter. But the point is, that's why trees sometimes just go crazy. But the point about the decision tree that's important is it's very intuitive, where you look and say, oh, it's split on a thallium stress test, which is 3 categories: normal, reversible, or fixed defect. And you can just see the percentages. And so you go down the normal thallium stress test, and then it divides under whether the coronary vessels were calcified, yes or no. If they were calcified, then you're much more likely to have heart disease, and you can see the statistics. But if your thallium was normal and you had no coronary arteries calcified, you can see that only 11% ended up with heart disease. I would suggest you play with this and get used to looking at the numbers. Keep in mind, this is not perfect. Not every algorithm views thallium as number 1. Most of them have it in the top 3, let's say, but this is a great, quick way to visualize a data set. Now, here's my workhorse. I have to say that I use this probably more than anything else to look at when I have a new data set. And the main reason is it not just does, say, a box plot. And let's just look at, for instance, age. We're looking at age of people with and without heart disease. The 0 up here means that people without the heart disease, and here's people with heart disease. So it gives you this interquartile range, 25 percentile here, 75 percentile here, gives you median and mean. But importantly, look down here where it gives you the p-value. So what does that mean? It's statistically significant, the age difference between those people who were found to have an abnormal cardiac catheterization, those who didn't. That's somewhat common sense. They're younger at 52 versus 56 on average, but that's super helpful. And you can then start looking also at categorical data. We can look at gender. And you can look at, is there a difference? I mean, you intuitively say there are more men with heart disease than females, but is that statistically significant? This is a chi-square test that we'll go over a little bit more detail, but it really just shows you the expected percentages against the actual percentages. And the answer is the statistically is different. Now, another thing about orange visualizations I can't emphasize enough is if you click on this, notice it highlighted it, you can send that to a data table. So, I could put a data table here and send it, and now I only have those people, 72 instances. So you can isolate data for any one of these. You can isolate data that way. And even the tree viewer, I won't do it, but you can click on this and send just that tree, decision tree, to a data table. So the box plot is really a very good beginning point, similar to the feature statistics, where you're trying to learn your data. Now, violin plot is just another way, and let's let me just pick cholesterol here. And you can get it to, let's see, well, that's good enough. So all this is really showing me, it's showing me all the different data dots or points in both of them, but there are more patients in this range of, say, roughly 220, 230 in those people without heart disease than those people with heart disease, if you look at 0 and 1 here. But there are more outliers in women, particularly women, by the way, than men. And keep in mind, again, you can always isolate these and look further, but this is just giving you an idea of the shape of your data with the violin plot. And sometimes that's helpful. It's not particularly elucidating in this case, but it can be. Distribution plot, again, particularly helpful if you have categorical data. This is age and versus diameter narrowing or heart disease. So you can see that here you have the people in ages, and this has to be binning. We can narrow that down. Anytime you look at this, you have to adjust the bin width, and it can change. So be careful. You know, do several visualizations with different widths, because it may make a difference in how you determine it. So here you're looking at, for instance, people that are almost 80, and it looks like the heart disease is so few people, it's not statistically significant. So if you, for instance, here, if you're 50-ish, you're more likely not to have heart disease. If you're 60-ish, you're more likely to have heart disease. You can stack the columns and look at it a different way. You can do something called kernel density, which draws a line like that to look at it. But a good way, again, to explore your data, remember that some of the old statistical tests, linear regression, ANOVAs, and so forth, prefer the data to be normally distributed. So in your early data exploration, you're going to want to look at each variable. Is it normally distributed, yes or no? You also, let's get rid of the line here. And once again, if you're interested for some reason, for instance, here's a group that's young, that's has heart disease. You can click on that and send it to a data table. I won't necessarily show that, but that's how you can help isolate people, into subgroups. Scatter plot is generally used for primarily looking at dependent variables, continuous variables, numeric, in other words. For instance, maximal heart rate and age. I think we already said that there is a relationship. The older you get, the less likely you are to have a high heart rate. And you can see the trend lines, is a negative 0.5, and you don't have to do it you can do it just like this, if you will. Let's go back to diameter narrowing, and you can again isolate strange patients. Like here, for instance, is somebody who at the age of, I think they're 67, their maximal heart rate was 71. Now, was that because they had terrible coronary disease and they had to stop the treadmill? Or do they have arthritis? We don't know without pulling their chart. But what you can do is click on it, highlight it, and send it to a data table, and it tells you more information. And also, as you mouse over it, it does that. Similarly, with a scatter plot, maybe you have a subgroup down here. You can isolate those if, this is a poor example, but you often have little clusters somewhere And so these people had a high heart rate, both with and without heart disease. You could isolate those and in a data table, here are those patients, and you could look further to see what were their characteristics. So those are the basic things we really want you to understand about data visualization. This is the starting point. We've only gone through 10. I'm going to stop the share. We've only gone through 10 visualizations. So at this point, what I want to do is I'm going to open it up for questions. We're not going to go too much longer, but I think it's time for interaction about any of the prior discussion, including ChatGPT, I might add, but also about data visualization, which we went over relatively quickly. So let me just see in the chat whether I missed anything.
No, there's nothing there that you missed.
Okay. All right, but now it's time. Let's spend the next 10 minutes, though, just purely on answering any questions or concerns people have about any aspect, including Orange, JASP, or any of the topics covered. Questions? Just unmute yourself and answer. Or I guess on this one, I don't know if you can show hands or not. I don't see that option. Let's see, Darren, let's see. Okay, so for the tree viewer, you have to connect to the tree. So you take the file widget to whatever data set you want, connect that to you have to go to model, then select the tree, and then select the tree to the tree viewer. So the tree viewer by itself will not work. Other questions? How about more global questions about the course, future direction of medicine, or how large language models may modify that? As you probably know, they're being used in coding all the time. It's one more reason we think coding may not become as important as you think. More and more programs are allowing you to use natural language and say, create a histogram, create a model, you name it. So you're seeing this even with SQL or SQL. You're seeing them now be able to use natural language. You type in, I want to select all females under age 40 who have heart disease in a database, and it'll query those patients. You didn't write any SQL code whatsoever. So I'm just trying to get you to understand where we are and where we're headed. So feel free to unmute and ask questions or start a discussion.
Could you say a little bit more about what is it called, Bing Chat? Because is that a paid model, or is the access restricted, or what's the deal?
No, and let me clarify that. Initially, when I heard Bing was going to add GPT-4, I went, great. I looked at Bing and I went, I don't see anything different. Here's the problem. You have to find Bing Chat. So it's not Bing and it's not Microsoft Edge. You have to install Microsoft Edge, and that's a trick that Microsoft does to get you to use their browser. But so Bing Chat is a free chat large language model that uses GPT-4, and it's free. It does an excellent job, and you should consider trying it to see how you can use it. So that was my point. If you want to go ahead.
Yeah, the Bing Chat is restricted to the Edge browser, though, right? You cannot use Bing Chat, let's say, on Google Chrome.
Right. It looks like you need to first install Microsoft Edge, and then I think search on it using that. That appears to be how you get to it. Yes. But I think, again, the plus is for that and Perplexity AI is not only do you get a very interesting answer, you also get references. All the other, I don't know of any other large language model that provides references, which is a bit scary. That's why I do not recommend you use ChatGPT for medical questions. It may be right, but there's a study out of Stanford that said it was wrong a surprising number of times. And some of the answers are uninterpretable. Some were faked. And then the third thing is they didn't like is they repeated their questions to GPT like 2 or 3 times more that week and got a different answer every time. So it's just that you may strike gold using Chat GPT with a medical question. I simply can't recommend it until it adds references so you can check on the validity of it. All right, David, let's see. What are your thoughts on the balance between becoming more operational? Well, what I would say is, first of all, the clinician is super important for a data science team. You add reality. Too many data science teams do something that's cool. They get a proof of concept paper out of it. It never sees the light of day. There ought to be clinicians on every type of data science project. I just think that's critical. But it is tough. It is tough to do both. And it's really tough if you're trying to learn medicine, you're trying to learn data science, and you're trying to learn a programming language. That's why we really can't recommend it. But David, I had a feeling you may have been asking a different question than what I answered. You want to unmute and ask the question?
Sure. Yeah, no, that was actually pretty close to what I was thinking. It's just at my institutional organization, we have like a data science team, but so I'm a pathologist. So my department is relatively small in compared to like the hundreds or thousands of primary care physicians. So let's say I wanted to do work on a project that would improve efficiency, or a data science project that just deals with the pathologist or pathology. It's hard to get buy-in from the data science team who have much bigger fish to fry. So I'm trying to find the balance of how much do I learn and how much do I take on the project, knowing that I'll have very little support from the data science side.
Yeah, that's unfortunately very true. And it's coupled by, do you have grant money? Yes or no? Because the reality is, if you're at an academic institution, so often they have to account for their time, and it's all about dollars and cents. So it is true that, the more global your project is, the more people you affect, the more return on investment, you name it, the more likely is your project will see the light of day. So it is a real, a realistic challenge that if you have something in your department that sounds really interesting, you're almost forced to get a grant so you can bring in outside help to pay for it. Now, in terms of, let me answer one other question I saw about Epic. Epic is working with GPT-4, by the way. It will be part of Epic, but we think initially it's low-hanging fruit. We think it'll simply navigate the electronic health record a little better. They're not really talking about clinical decision support using the full maximum power of a language model, but they absolutely are on a group of about 15 companies that are already pretty well have committed to using GPT-4 in their program. There are plenty of other ones, but Epic is the one that stood out. Let's see.
And then also here, Hassan was saying that Chat GPT generates fake citations for essays.
Yeah. No,
You
I
gotta
didn't. I
watch
have not
out.
heard. I've not heard that. I'm not surprised though. Let's see. We're about to have our paper published on answering board type questions in ophthalmology. Well, that's interesting because there's lots of data on GPT 3.5 and 4 taking the MedCats and the LCATs and all these standardized tests. That's already out there. You probably know. Just go to OpenAI website and you can find all these benchmarking studies. But I have not seen the questions in ophthalmology. Which Abdullah? Which board questions are you talking about? Have you extracted those out of regular medical boards or or the Board of Ophthalmology or what?
Yeah, so it's basically Board of Ophthalmology. We use the questions that are available on AAO website. It's kind of the USMLE for the, it's kind of like the, I would say, MBME for the USMLE. So we are using some from the official site. They have sample questions. We use that, and we experimented with 3 models, like the Bing Chat, the ChatGPT 3.5, and ChatGPT 4.0.
Okay,
We can, yeah.
that's great. I mean, we keep learning. It's like building a building with bricks. You know, you're putting the cornerstone in right now. You're starting the bricks. Each time you add a new brick, we know a little bit more. And just to comment about GPT-4, I see David put something about Wendy's, the Khan Academy, Morgan Stanley, the list goes on and on and on. And keep in mind, on top of that, to make to stir the soup a little harder, there are at least 15 add-ons to ChatGPT about to be released. In other words, like hotels.com, whatever, they're all going to integrate. They're all buying, basically, they're buying access to GPT 3.5's API, the application programming interface, so they can, you know, they'll rent that or lease it. And that's how they're paying for it. It's very cheap to use GPT 3.5. However, it's said that GPT-4 will be 50 times more expensive. I'm just mentioning that. So, but more and more companies are going to try to integrate it as a better search engine, a more intelligent search engine. Other comments in that arena? I appreciate you all providing that feedback.
Are these like, I didn't view Chat GPT as a search engine. I kind of view, and please correct me if I'm wrong, as an easier way to communicate with a search engine, so that I can ask a search engine what I want in natural language, rather than having to type, you know, specific prompts or specific way of asking, so that I can get the information I want. Could you help?
Yeah,
with that?
you were absolutely correct. That was a slip of the tongue. In other words, these large language models will augment and change really the landscape of all search engines, whether you're talking about the internet or you're talking about, say, UpToDate. I think it's just a matter of time where a huge online resource like UpToDate is going to have a large language model. It is, you're absolutely correct. The whole idea is to use natural language to perform something. It might be a search, or in the case of some of these auto GPT things, it would be to create an entire process. I want you to design a website that does the following 5 things. So it is all about using natural language to do something, and that includes search engines. So thank you for that clarification. You're absolutely right. We're pretty much where we're supposed to be for this length of workshop. Any other comments before we close?
Just wanted to ask, anyone experimented with the board, Google?
What about Google Bard?
Yeah.
I think that the reviews right now are not very good. Even their own employees were not very impressed with it. It seems to be more backward than GPT 3.5 and certainly 3.4. So, however, they're working hard to change that. There are humans in the loop, by the way, on several of these. GPT-4 had many humans working to make it better. Bard does. Glass Health has many physicians providing input. So just keep in mind, it's not totally, they even use reinforcement learning. I won't get into it. We'll cover that. So it's a large language model plus reinforcement learning. We'll cover that later. So if there's no other burning issues, I think we'll call it a day. I appreciate your attendance And we'll look forward. The next time we'll finish up on visualization. Hopefully we'll finish the chapter, maybe, maybe not. Feel free to email me or Dave if you have follow-on questions or concerns. Don't forget the homework, okay? All right, have a good weekend, and thank you again for your participation.
Take care, everybody.
Bye-bye.
Bye.